Welcome to this lesson on an intro to surface area. Surface area is the sum of all the area of the faces of a 3D figure. So if you take each face, for example, on this cylinder, if you opened it up and laid it out, it would have a top circle, a bottom circle, and then this section, if you open it up, it would basically be a rectangle. So if you found the area of this circle, the area of this circle, and the area of the rectangle, added them all up, that's what sum means, then you would find the total surface area. And this here is actually called a net. It's a 2D pattern of a 3D figure, and it helps us to see the different shapes that make up a three-dimensional figure. All right, a couple of different types of faces that you will see. First of all, a base is the bottom and or the top of a 3D figure. So on a cylinder, it has two bases, the circular bases. So this is a base and this is a base. Some 3D figures just have one. Some 3D figures, like a sphere, have no bases. And then a lateral surface is basically the other surfaces, so the faces that are not bases. So this would be a lateral surface. All right, so let's try some of these examples. So identify the 3D shape that could be formed by the net below. So basically, if you put these shapes back together, so they're not flat, but they're making a 3D shape, what kind of 3D shape would it make? And this one is going to be a square pyramid. So this would be the base of the pyramid. It's a square. And then if you brought all these triangles together and touched them all at the very top, then it would make a pyramid. Number 2, how many bases does the pyramid below have and how many lateral surfaces? So a base is like the bottom. So it just has one base, this rectangular base here. And then all the other faces would be lateral surfaces. So it has this top, this front triangle, then it has the two side triangles, and then it would also have this back triangle too. So it has 4 lateral surfaces, and they're all triangles. All right, number 3, draw a net for a cube. So basically think about, okay, a cube is made up of squares. See if you can count how many squares it would be. So we have the top and the bottom. Then we have the 4 sides, so that would be 6. And you can kind of draw them however you want. Usually with a cube, you see the net like that. That's a very poor drawing, but you get the picture. Number 4, if a 3D shape has 2 bases, what must be true about the 2 bases? So let's go back to a 3D shape that we know has 2 bases. That would be the cylinder here. Think about what you know about those 2 circular bases. First of all, they're the same size and shape, so they are congruent. But if you look at the 3D shape, they're also going to be parallel. So if you have 2 bases, they're going to be congruent and parallel. Same thing with this cube here. It has this base and this base. Those squares are congruent and they are parallel. All right, let's go on to rectangular prisms. So a rectangular prism is a 3D figure where all the faces are squares or rectangles. So I have the net here of this prism. So if we want to find the surface area, basically we just need to find the area of all those different rectangles. Remember, the area of a rectangle is the length times width. So for example, if we start with this one, the length is 7, the width is 5, or you could switch it, it doesn't matter. 7 times 5 is 35. Same thing for this one, this would also be 7. All right. Then we have, let's start with this top rectangle. So we have 7, and this would be also 16. So 7 times 16 is 112. The next one is still 16, but it's 16 by 5. So that would be 16 times 5 is 80. This one again would be 7. I know that because this is 7 here. 7 times 16 is 112. And then the last one is 5 by 16, so 80 again. So if we want to find the total surface area, basically we need to add all those areas up. So 112 plus 80 plus 112 plus 80 plus 35 plus 35. That will give us the total area. When you add that up, that's 454 inches squared. There's also a formula if you want to use the formula. 2 parentheses width times length plus height times length plus height times width. So you can also use that formula. And then a cube is a special type of rectangular prism where all the faces are squares. All right, so we have the net here. So all of these are going to be 3. Because it is a cube, they're all squares. So 3 times 3 is 9. And they should all be the same for a cube. So they're all going to be 9. They're all squares. So basically we have, let's see how many squares. 1, 2, 3, 4, 5, 6. So we could say 9 times 6, which is 54 feet squared. It's area, so it's always going to be units squared. There's also a formula for a cube, which is 6 area squared. And that's basically what we just did. We found the area of one of the squares, 9, and then we multiplied it by 6. All right, let's try these examples. So the surface area of a cube is 150 square feet. What is the length of one of the sides? So this one we're working backwards. We know that surface area of a cube is 6a squared. We're given the surface area is 150, and we want to find A, which is a length of the side. Go ahead and write that at the top. A equals a side length. So in this case, that would be 3. All right, so I'm going to divide both sides by 6. That gives me 25. 6 divided by 6 is 1. All right, and then I'm going to take the square root of both sides. So that would give us 5. So a side length would be 5 feet for this one. All right, number 4, the dimensions of a gift box are 12 inches by 4 inches by 5 inches. How many square inches of wrapping paper are needed to cover the box? So wrapping paper would be the surface area. So since we don't have a net here, you could draw a net if you would like, or you can use the formula. The formula is not too bad for a prism, so I'm going to use the formula. So the formula I wrote right up here. You can rewrite it if you want. And it really doesn't matter which one you label as width, length, and height, because it really depends on which way the box is standing, if you have it upright or if you have it laying on its side. I'm just going to label it in order. WLH, and then I'm going to substitute into my formula. So 12 times 4 plus 5 times 4 plus 5 times 12. So that would be 48 plus 20 plus 60. Then I'm going to add all those up. 48 plus 20 plus 60 is 128. And then times 2, that would be 256 square inches of wrapping paper. Now, of course, you're probably going to use a little bit more than that, but that's the minimum you need to cover the box. All right, you can go ahead and stop the video now and complete your practice.